how far away are we from a vaccine? There's also the issue of testing. Do current tests target the antigens, or can they also determine the antibodies being produced by a human? To discuss these issues, we have with us Dr. Tang. Dr. Tang is the Division Chief of Pathology Sciences at Sidra Medicine in Doha. In this role, Dr. Tang is responsible for the development and implementation of new molecular and genomics-based tests for microbiology and infectious diseases. Thank you for joining us, Doctor. Let's begin with a non-technical distinction between RNA and DNA viruses and what that means for developing a vaccine and inoculating humans.
So in general, DNA viruses tend to mutate at a slightly slower rate than RNA viruses, but that's a very general statement. There's different types of RNA viruses, there's different types of DNA viruses. So if we're talking about this coronavirus, it does mutate relatively quickly. So every copy that the virus makes of itself inside of a cell will have one error in it. The thing that we have to note that most of these mistakes or mutations are neutral in that they neither harm the virus or make it more virulent. So most of these mutations don't make any difference at all for the virus.
So why is it that DNA virus, all viruses mutate, but why is it that the DNA viruses mutate much slower compared to RNA viruses?
So I'm generalizing, but some of the DNA viruses, if they tend to have two strands to the DNA, there's an extra strand to it that allows it to do some error correction. And many of the RNA viruses don't have enzymes packaged inside the virus to help correct for any mistake that it makes. But there's a lot of pressure on the virus. So whenever the virus makes a big mistake in the genome, in the RNA, that virus might not replicate anymore. So then those ones will die off. So there is some pressure within the virus population to maintain a certain sequence. So all the defective viruses can't replicate. So those ones don't work.
Okay, so when we